Imagine standing on a vast dark beach at night. The sand stretches endlessly in all directions. Above you, countless stars twinkle like celestial fireflies. Each point of light represents a distant sun, many perhaps harboring their own planets. Now, imagine you could suddenly zoom in on one tiny speck of light so faint it's barely visible to the naked eye. As you get closer and closer, the speck transforms into a swirling galaxy, a majestic city of stars. This, in a way, is the power of the James Webb Space Telescope, our most powerful eye on the cosmos. It allows us to peer deep into the universe's past, witnessing the birth of stars and galaxies in the aftermath of the Big Bang. The JWST is often described as a time machine. This isn't just poetic license, it's a fundamental aspect of how telescopes work. Light travels at a finite speed, and the vast distances in space mean that the light we see from distant objects has taken billions of years to reach us. When we observe these objects, we are seeing them as they were billions of years ago, when the universe was young. The JWST, with its unparalleled sensitivity and resolution, can detect the faintest glimmers of light from the most distant galaxies. This allows us to look further back in time than ever before, closer to the universe's beginnings. The JWST has already made groundbreaking discoveries, but perhaps none are more perplexing than the detection of massive, mature galaxies that existed much earlier than thought possible. These galaxies are so ancient that they challenge our fundamental understanding of how the universe evolved. According to the prevailing cosmological model, the early universe was a chaotic soup of hot, dense particles. It took hundreds of millions of years for this soup to cool and coalesce into the first stars and galaxies. Yet, the JWST is finding galaxies that are too big and too well-formed to have existed so early in the universe's history. Section 4. The puzzle of precocious galaxies. Imagine planting a tree and expecting it to take decades to grow into a towering oak. Now, imagine returning a few years later to find a fully grown forest where you planted that single seedling. This is akin to the bewilderment astronomers are facing with the JWST's discoveries. These ancient galaxies are like cosmic overachievers, defying the expected timeline of cosmic evolution. Their existence implies that our understanding of the early universe is incomplete. It's like finding a finished skyscraper in a world where we thought people were still figuring out how to build huts. Section 5. Rewriting the Cosmic Playbook. The discovery of these anomalous galaxies has sent ripples of excitement and uncertainty through the scientific community. Cosmologists are scrambling to explain how these galaxies could have formed so quickly and efficiently. One possibility is that the expansion of the universe is happening faster than we thought, meaning the early universe was denser and more conducive to rapid galaxy formation. Another possibility is that dark matter, the invisible substance thought to make up most of the universe's mass, behaves differently than we currently understand. Section 6. A universe full of surprises. Perhaps the most radical idea is that the Big Bang, the event we perceive as the beginning of the universe, wasn't actually the beginning at all. Maybe it was just a transition, a cosmic reboot. Maybe our universe existed before the Big Bang, and these ancient galaxies are remnants of that prior epoch. Whatever the explanation, the JWST's discoveries are a stark reminder that the universe is full of surprises. They are forcing us to question our assumptions and to embrace the unknown. The universe, it seems, is far stranger and more wondrous than we ever imagined.